take a look at some of the properties of continuous random variables now that we know what these things are. And the first thing we'll take a look at is the expected value, or the mean, of a continuous random variable. Now, one of the things to recall is that we've met the expected value before when we talked about discrete random variables. If you remember, in the discrete sense, it was just a case of taking each outcome and multiplying it by the corresponding probability and then adding them all up. Now, the continuous result is very similar. We just have to remember that I can't sum a separate number of values in the continuous case. I want to do a continuous sum, if you like. And if you remember back to our integration work, then we can consider integration as a continuous sum. So the corresponding result here, instead of the sigma sign for the sum, I've got an integral sign, but the thing in the middle is actually the same. I've got x. In the continuous sense, the probability is not defined by the probability function, they're defined by the probability density function. So the result for continuous random variable is this, the integral between infinity and minus infinity of x times f of x. We'll see how that works in a moment or two. If we move on and look at the next thing of interest, no great surprise, to look at the variance of a continuous random variable. Now, we've met variance of random variables before. We've come across these results, which are still true for continuous random variables. These results are true whether it's discrete or continuous. If we think back to the result for the discrete random variables, then we'll remember that it was the sum of x squared times the corresponding probability and then subtract the mean squared. So using the same idea, I can just write down the corresponding result for a continuous random variable. So instead of the sum of a discrete number of things, I'm going to integrate over the interval infinity to minus infinity. The x squared, instead of the probability function, I've got the probability density function with respect to x, and then subtract the mean squared. So this is the corresponding result for the variance of a continuous random variable. Let's take a look at how these results work in practice. So I've got an example. I've got a continuous random variable with a probability density function given by this. This is actually the one that you looked at in the last example. I'm probably interested to see what this looks like. So, of course, if I've got my calculator handy, I can draw it, no problems. But, of course, I can also sketch this, hopefully quite happily, realising that this is a quadratic between minus 2 and 2 are actually the roots of that function. So I can quickly sketch the function that looks like this. If I go on to find the mean of this random variable, then I need to remember the formula. So we've got this. Remember that the formula had the limits of infinity to minus infinity. But because beyond 2 and beyond negative 2 this function is defined as 0, the limits in this case are between 2 and minus 2. So this is always the bit that it's doing something interesting. So I can calculate that by hand if necessary, but of course if you've got your calculator, I can exploit some of the shortcuts. So let's go add a page, add a calculator page. I'm going to go menu, 4 for calculus, 2 for numerical integral. Let's just see if you can see that clearly on the screen. Let's put the limits in from 2 to minus 2. Then the integral of x times, I don't even have to type out the function. Because I drew the function on the previous page, that function is already stored as f1. So I can punch that in quickly. You can see this is going to be a very quick way of obtaining these answers. So the answer there is 0. Now, actual fact, I shouldn't be surprised because this function is symmetrical about 0. So I could have written this answer down if I'd have used the symmetrical property that's evident from the diagram. So look out for that as a way of, again, shortening the methods that you're going to be asked to use. Second question often follows find the variance. So again, I just need to call upon the appropriate formula. Go to my calculator to exploit this again. Let's go. Menu, 4 for calculus, 2 for numerical integral, between limits of 2 and minus 2. X squared times variables f1 of x with respect to x. Now, the classic mistake here, of course, is then to forget to subtract the mean squared. Now, in this question, of course, it wouldn't matter because the mean is 0. But a common mistake is to forget to subtract that mean squared. So if we do that, then I've got the answer of 0.8 or 4/5. So I've got the variance of this continuous random variable. If I'm asked for the standard deviation, it's just a case of then recalling the standard deviation is the square root of the variance.